So let's do a quick revision of the topics covered in the last class and then we will continue. So we are at day 3 today. Okay. So guys, tell me what topics did we cover in the last class? So first let us talk about the data types in R. So I believe everybody has R installed, right? So guys, everybody has R installed on your systems? Yeah, please install, okay? Vagish, do you have R installed? Okay, great. And guys, how many of you completed the homework that I had sent? I sent out a homework last week, right? Anybody who completed it? Okay, great. So Devmita good, was able to do 6 questions. Okay. What about the remaining, Niranjan? You didn't try, you didn't get time, or you were not able to do? Okay, good, Ravi. Okay, didn't get time. So that is why you should have started. So from next week onwards, I'll try to send the homework assignment as soon as possible. So I think this week I sent it pretty late. I think I sent it on a Wednesday, right? I should have sent it by Monday or Tuesday itself so that you get more time to finish the assignment. Okay. And guys, please make sure you do the assignments. Okay. Because if you keep any backlogs for the next week you might have a new assignment coming. So the backlogs will keep binding basically. Okay. So that should not happen. The backlogs will go on accumulating and at some point it will become too much to handle. So please start working hard from the first week onwards so that you can have things in an ordered way. Don't keep things pending for the next week, because next week will be even tougher than the first week. Okay, so this course, the complexity of the course is like a staircase. It increases as you go with the course. Okay, so don't keep anything pending for the next week. Next week might be even tougher than what you expect. Okay, great. And any doubts on the homework, feel free to discuss in the WhatsApp group. Okay. So it took me almost 2 to 3 hours to create that homework. So please do that homework. Okay. I spent a lot of time doing that. I have not just copied the homework from somewhere on the internet. I have created it myself. Each question I have thought over the questions and then I have created it so that you get maximum benefit out of it. Okay, guys. So let's start with the revision now. So what did we see in the last class? So let's discuss the data types that we saw in the last class. So what was the first data type that we saw? So this will be an overall revision of all the things that has been covered so far. Okay. So so Abhilash, I think you are attending for the first time. So this would be a good revision for you. So yes, guys, what data types did we cover? Okay, vectors. So the first data type that we cover in R was vector. So what is a vector? A vector is a collection of elements. Okay, a vector in R is a collection of elements, and the point to note here is all the elements should be of same data type. Okay. Yeah, a collection of similar data types. That is what we saw. We assign a vector by using the C operator or C function, you can say, small c. Okay. So you define a vector, for example, x as C of, you can give multiple elements here. Okay, followed separated by comma. So this means that x is a vector which has 3 elements, 1, 2 and 3. Okay. And all the elements must be of the same data type. You cannot have a string and a number. Okay. So for example, if you write x is equal to 1, 5 and let's say 1. If you write this, what will happen? Yes, guys, tell me. If I create a vector in this way, what would happen? Yes, guys, please answer. Yeah, all would become string. So it yes, exactly, Abhilash, you are right. Okay. So it won't throw a error. It won't throw a error because you have two data types in a single vector, but what it will do is it will convert these to a string as well. Okay, it will convert these two integers to string and make them of the same data type. So that's what R will do. Okay, so this is all about vectors. We also saw indexing in vectors. So what is indexing in vectors? The indexing starts from 1 in R. Okay, so for example, index of this element is 1, index of the second element is 2, and so on. Now you can access individual elements of a vector by using square brackets. So you can write x of 1, what you will get is 1 as the output. Similarly, you can write x of 3, you will get 1 as the output. Okay, this is the third element of the vector. So you can use this. And what if you write x of minus 1? If you write x of minus 1, you will get all the elements except the first one. Minus 1 means except the first one. So you will get 5 and you will get 1. This will be the output. Okay. So I hope vectors is clear to everybody. Okay. Next we saw matrices. So how do we create a matrix in R? So we use the function of the same name. We use a function called matrix, and we give a few inputs is provided to this function. So what is the first input? What do we give as the first input? Yes, guys. What is the first input that we give? Not the row size. First, we have to give what are the numbers we want in the vector. So what data do we want in the vector, right, Devmita? What numbers do you want? So what numbers do you want in the matrix? So let's say I want 10 to 20. I want these numbers in the matrix, so I will give those numbers. And 10 colon 20 means 10, 11, 12 till 20. This is what it means, okay? Now after this I will give how many rows do I want. So I will give that by the parameter n row. N row I can give, let's say 5. That means I want 5 rows in my matrix. Okay, and then I can give n call also, but this is not mandatory. Even if you don't give this, it will compute. Okay, it will compute automatically and give you the number of columns. Can we give vectors in place of data element? I think yes, Devmita. I have not tried this, but I guess you can. Yes, you can, because this is nothing but a vector. So you can give a vector also. Okay, you can. So you give the number of rows and you give the number of columns, and you also give an optional argument which is by row is equal to true or false. Okay, so this is optional. This is also optional. So what does this do? So we understood what is this. This is the data that we want to put in our matrix. This is the number of rows that we want. This is the number of columns that we want. By row, if you give by row is equal to true, what it will do, let's say 10 to 20, it will start filling the numbers by row. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, it should have been 11. Okay, then it will be proper. Okay, so this is how it will fill if you give by row is equal to true. But if you give by row is equal to false, sorry, this will be by row is equal to false. Yeah, it would be the other way around. Okay, by row is equal to false, you will get this. And if your by row is equal to true, then you will get like this: 10, 11, 12, 13, 14, 15, and so on. Okay, so by row decides how will your values be filled. Should it be filled by rows first, or should it be filled by columns first? Okay, so I hope this is clear to everybody. Guys, is this clear? Matrix? Okay, great. And we can also do indexing of matrices. Okay, we can also do a two-dimensional indexing. So how do you do a two-dimensional indexing? Separated by commas, you give the rows that you want and you give the columns that you want. Okay, this is how you can index. So for example, if you want let's say these two. Okay, so we know that these two are in row number 3, so you can write row number 3 and they are in column number 1 and 2. So this is the first column, this is the second column, so you can give 1 comma 2. Okay, you will have to use C because you are using more than one, so this C will appear. So this means third row you want column number 1 and you want column number 2 in the third row. This is what it means. Okay, you could have also given it 1 colon 2. This will also work. Now you don't have to use C because colon automatically takes that into consideration. Okay, or in other way you could have also done it like you could have just left it blank. Blank means you want all the columns. We only have 2 columns here, so it will print all the columns. Okay, so the same operation you can do in multiple ways. So which rows do you want, which columns do you want? This is for two-dimensional indexing. Okay, is this clear, guys? Okay, so all this is discussed in details in last week's video. So if you feel you're not very comfortable in this, we saw a lot of examples. So today we are just doing a revision. We see a lot of other examples also on the same things in the last week's video. So for detailed explanation, you can always refer to the last week's video. And guys, I will be uploading the videos on a YouTube channel. So I have a YouTube channel. I'll be uploading those videos on another YouTube channel, which I'll be sharing with you soon. Okay, so right now the videos are not in the YouTube channel. I have just placed it in some random place, but I'll be uploading it on a YouTube channel, and that YouTube channel will also have Python videos. So I also take classes in Python. So Python classes is almost done now. So I have also uploaded the Python videos there. So anybody who wants to learn Python also can learn Python. That is for free basically. You won't be paying anything for that. It is on the same YouTube channel. The same course that we are doing now, the same course will be available, but it is in Python. Only the language changes. The concepts, everything remains same. So maybe after a few months, if you want to learn Python, if you are clear with machine learning in R and you want to learn Python, then you can always refer the videos. You won't have to pay anything for that. Okay. Okay. So this is about matrices. What else did we cover? Yes, guys. What else did we see in the last week? So let me open up. Okay, so I think this was all that we covered in R, and we covered a few basic statistical concepts. Let's review the statistical concepts now. Okay, so on R, this is all that we covered. Okay, so people who are attending the class for the first time, you haven't missed anything, in fact. Okay, just 2 data types which you can quickly revise. Okay, now let's come to the statistics that we covered. Okay, so this is very important. So we are starting with the very basics of statistics, and we'll be slowly building on top of this. So the first thing, so statistic is divided into 3 parts. First is descriptive statistics, then we have probability, and then we have inferential statistics. Okay, so we were talking about descriptive statistics. We are yet to go into probability and inferential statistics. We were discussing about descriptive statistics. So why is it known as descriptive statistics? Because it is used to describe a population. Okay, whatever we will be learning in descriptive statistics, whatever parameters we learn in descriptive statistics, will be used to describe a population. Okay, hence it is known as descriptive statistics, because you describe a population. It is used for descriptive purposes. So what are the parameters that is used for describing a population? Yes, guys, can you tell me what are the parameters we use to describe a population? So let's say your population may be all software professionals of Bangalore. This is your population. Okay, all white collar workers of the city of Bangalore. So what different parameters can you use to describe them? Yeah, so maybe you can use the mean. So we are talking about salaries, okay? Salary or income of all software professionals of Bangalore. So we can use the mean to describe that. We can use the median to describe that. We can use the mode to describe that. We can also use the standard deviation to describe that. We will see what is standard deviation. So mean everybody understands. Yeah, we also have variance. So these are few parameters which is used to describe a population. Hence, they all fall under descriptive statistics. Okay. So mean everybody knows it's the simple average. It is the simple average. So take everybody's salary and divide by the number of people. You will get the average. Okay. What is the median? Median is the 50th percentile. The 50th percentile who falls in the middle. Okay. Then mode everybody understands. What is the mode? So which particular salary most people have basically. So that is the mode. Okay, this again comes from high school. Then we learned something new in the last class, which was standard deviation. So anybody remembers the English definition of standard deviation? We saw English definition and we saw mathematical definition. What was the English definition, guys? No, Vagish, it was not root mean square of average. Okay, it was root mean square of deviations from average. Okay, so the word deviation is very important. So Satish, you are right. Yeah, it is root mean square of deviations from average. So I can write root mean square of deviations from average. Okay, so this is the English definition. Now let us write the same in mathematics. So we will start from the right side. So first we take the average. So let me write the average here. Then we calculate the deviation from average. Deviation of what? We calculate the deviation of each point from the average. Okay, all the points that you have, you will calculate their deviation from the average. So average means, for it in this example, average might be the average salary of everybody, all software professionals. Okay, you got the average. Now you will have to see how far is each person from that average. So you will take everybody's salary and subtract it from the average to get the deviations. Okay, so this is your deviations from average. So how far is everybody from the average, the deviation. Okay, then you square it. So I will square it, then take the mean of it. So you take the mean of it, assuming you have n people here, and then you take the square root. You take the square root now, and of course, since you are using I here, I will go from 1 till n. So this is the formula for standard deviation. Okay, I hope everybody will remember this formula now. Just remember the English definition. If you remember that, you can always derive that mathematical equation from the English definition, and it's quite easy to remember. Root mean square of deviations from average, RMS of deviation from average. Just repeat this 10 times, you'll remember. Okay, so this is your standard deviation. And we also saw another parameter called variance, which was nothing but standard deviation whole square. This was your variance. So what is the unit of standard deviation for this example? Let's say, what is the unit of standard deviation, guys? Rupees, right? So it is rupees, because we were talking about income, right? Income of all software professionals. So income will be in rupees. So the unit of standard deviation will be rupees. Okay, and what will be the unit of variance then? Yeah, it is rupees whole square. Okay, because you squared the values, so obviously the units also will get squared. So it is variance is rupees whole square. That is why standard deviation is more popularly used. Variance is not popularly used because it is very difficult to interpret, because the units are squared. But this is simple to interpret. You get some number and which has the same units, which you can directly interpret. Okay. Now what is this is the definition of standard deviation. This is the formula for standard deviation. We also saw what is variance. But what is the significance of these parameters? What is the significance of standard deviation or variance? What is their significance? Can somebody tell me? So why are they used? What do they represent? What do they indicate? Okay, so Satija says it measures variability. Okay, variability from what? So they must measure variability for something, right? So what is that? Okay. So Mrityunjay says to find how much in a population there is deviation from average. Yeah. So that is very important. That is what I was looking for. So they don't just measure variability; they measure variability from the average. So they should have some benchmark, right? From where they will measure the variability. So that benchmark is the average. So they measure how much is each value different from the average. Okay, guys, is it clear? They measure how much is each value different from the average. So for example, you get some value of average salary of all software professionals. Now the standard deviation will measure how much is each person's salary different from the overall average. That is what it will measure. Okay, and that is why we have this average here. This is very important. So deviations from average. So both standard deviation and variance, they measure variability from average. How much is each value different from the average is what they measure. Okay. We saw some examples also in the last class. So all these discussions were done in details in the last class. So we saw some one usage of this where two person basically wanted to invest in stocks. So which stock should they choose? Should they choose a stock which has high variance or high standard deviation, or should they choose a stock which has low standard deviation? Okay. So of course, a stock which has low standard deviation has less risk. Okay, because it has less standard deviation. It varies very little from the average. So it looks something like this. The average is 50, it goes till let's say 60, and on the bottom side it might go till 40 only. But another stock which has high standard deviation, it might look something like this. The average is 50, it might go till let's say 100, but at the same time it might go till 10 rupees also. So this is a risky stock. Okay, but this is less risky because it doesn't vary a lot. It almost stays close to its average. So you will not gain a lot here, but you will not lose either. Okay, and vice versa for the risky stock. So that was one small usage of standard deviation or variance. Okay, next we move to univariate analysis. We move to univariate analysis. So what did we see in univariate analysis? What does it mean, univariate analysis? Yes, guys. Uni means one variable. Okay, so that means analyzing one variable at a time. Analyzing one variable at a time or studying one variable at a time is univariate analysis. Okay, So whatever we are doing here is also in fact univariate analysis. We were just studying the salary of all software professionals. We were not studying their age or their total work experience, which company do they work. We were not studying all of that. We are just studying one single variable, which is salary. So this is also univariate analysis. Okay. So what did we see in univariate analysis? What was the first thing we saw? Yes, guys, what did we see in univariate analysis? Yes, histograms. Yeah, histograms, and then we will see the outliers also. Vagish. Okay, so let's see what is a histogram. So histogram, basically the purpose of a histogram is to show the distribution of a variable. Okay, histograms are used to show the distribution of a variable. Okay, so what is distribution of a variable? So when we do a descriptive analysis, when we do a descriptive statistics of the variable, so for example, we saw what is mean, median, mode, standard deviation, variance, and all those things, right? So they have a major disadvantage, and the disadvantage is that you just get one value, one parameter, but you don't get a lot of information. You might lose the original shape of the distribution. So if you see the average of all software professionals, you will just have the average. You will not know what is everybody's salary. So let's say if you have surveyed 20 people, you will not know the salary of all 20. You will just know the average. Okay, or you will just know the standard deviation. You will not know what is the exact salary of every individual. So that you lose when you do descriptive statistics. So when you draw a histogram, you don't lose any information basically. So you collect everybody's salary and you place it. So you note down everybody's salary and you plot that on the x-axis. Okay, you plot that on the x-axis. So let's say the salary starts from 2 lakhs. So 2 lakhs and goes till, let's say, 20 lakhs. So you have their salary, and what will you have on the y-axis? Yes, guys. So this will be your income. What is on the y-axis, guys? The frequency. Yeah. So the frequency. So for example, the salary starts from 2 lakhs. So you will want to know how many people had salaries of 2 lakhs. So in the entire city of Bangalore, or in the people you chose, among the people you chose to survey, how many people had a salary of 2 lakhs? So let's say it was 10 people. So let's say you surveyed only 50 guys. So out of 50, 10 guys had a salary of 2 lakhs. So the height of this bar at 2 will be 10, because 10 people had this salary. Okay, the height will be 10. Similarly, for all other salaries also, you will have some heights. So let's say you had one guy whose salary is 20. So the height will be very small. So this value will be maybe 1. Okay, and so on. So you will have some blocks like this. You will have some plots. And if you connect all of these bars like this with a curve, so we usually denote it with a curve like this. So this becomes a histogram. So this is a histogram of the income of all software professionals in Bangalore, or 50 software professionals in Bangalore. This is their histogram. Okay. Now in a histogram, we can denote where the mean and where the median lies. Okay. So let's say, for example, this is a histogram. I have drawn a histogram of whatever variable. Imagine some variable. Now where do you think is the average? So let me give you two hints. So I have 1 point here and I have 1 point here. So which one is the median and which one is the average? Okay. So yeah. So this is your median. Okay. And this is your mean. Why this is your mean? Because even if you have a few guys whose salary is a lot, they will pull the mean towards themselves. Okay, they will pull the mean towards themselves. We saw this in details in the last class. So if you're not sure why this is happening, please refer to the last class video. Okay, so a small example I can give you. Let's say we have salaries of 2, 4, 5, 2 lakhs, 4 lakhs, 5 lakhs, and there is one guy whose salary is, let's say, 80 lakhs. Okay, now what will happen because of this one guy? The average will be pulled towards himself, towards him. The average will go towards him or her, whatever, whoever he is. The average will be pulled towards that 80. So this mean will become huge because of these few guys who have a high salary. Okay, but what about the median? The median will still be in the middle. The median will not be affected because of this guy. Okay, so the median will still be here. So the median is nothing but 50% of the area. So this is like 50% of the area. Okay, and mean is the point where the histogram would balance. So imagine this to be a seesaw. If this is a seesaw, where would that seesaw balance is where the mean lies. Okay, so this would balance somewhere here. If you put it here, this side will become heavy because you have these people very far from this. Okay, so this is how you decide median and the mean. The important point to note here was that the mean is influenced by outliers. This is a very common interview question. The mean is influenced by outliers. The median is not. The median is not influenced by outliers. Okay, and you find the median after arranging in increasing order. So don't forget that. You first arrange all the numbers in increasing order and then you find the median. So this is about the histogram. What else? Okay, so Devmita has a question. Yes, Devmita, both will change. Both will change, of course. But if you add outliers, the median will not change. But if you add any data, the mean, let's say I add 3 here. So if I add 3 here, it will be somewhere here. Then the median, previously the median was 4.5. The median now will become 4. Okay, the median now will become 4. Okay, so both will change. If you add some values, both will change. But if you add outliers, then your mean will change more than the median. Okay, the mean will change more. The median will not be affected. But obviously there will be some changes, but negligible amount of change. Okay, so for example, let's say you have 3, 5, 80. Let's say 3, 5, 11 and 80. So right now your median is 5. Your median is 5 now. Let's say you added 1000 here. You added 1000 now. Now what will be your new median? Your new median will be 11. So the change was not a lot. But think about the average. So previously whatever was your average, it will jump a lot. The average will change a lot because of introducing this 1000. Okay, but the median will not change a lot. So small changes. Okay, so mean is influenced by outliers, median is not. Okay, yeah, so what else did we see, guys? Let me see. Yeah, so this histogram that we saw was a right skewed histogram. Okay, the histogram that we saw here, Nijaguna, yes, the classes started at 1 today. I had checked the timings, right? Didn't you check? We didn't start at 1:30, we started at 1. So the timings are not frozen at 1:30, guys. It will vary slightly. Okay, sometimes it will be 1, sometimes 1:30, sometimes 2 also. So please have a look at the WhatsApp group. Yeah, I had posted in the WhatsApp group. I thought everybody would have seen it. But no issues. You haven't missed anything. We are just doing a review. We are revising. Okay, we have had some new students come today, so we are revising. Okay, so that is all about histograms, and these kind of histograms which has a right tail here are known as right skewed histogram or right tail histogram also, because they have a right tail. Okay, right side tail. And whenever you have a right tailed histogram, always you will have the mean will always be greater than the median. Okay, when you have a right tailed histogram. So next we saw box plots. So what was box plots? What was the usage of box plot? Yes, to identify outliers. So the usage was to identify outliers in your data. Okay, so what are outliers? Outliers are values which are totally different than the other values. It might be very small values or it might be very large values. Okay, so we have to identify the outliers. Why do we identify the outliers? We will see that during machine learning. Okay, because outliers, they badly influence our model. Whatever prediction models that we will build, whatever machine learning models that we build, outliers will badly influence them. Okay, our predictions might go wrong because of the outliers. So we have to identify the outliers and we have to get rid of them. How we get rid of them, that also we will see later. But first we are just studying how to identify outliers. Okay, so box plots are commonly used to identify outliers. What is a box plot? So what do you have on the y-axis in box plot? Yes guys. Yes, exactly. So you have the variable on the y-axis. Okay, so let's say we were talking about income. So you have income on the y-axis. So the box plot will look, as its name is, it will look like a box, and you will have a few lines here. Okay, so these are known as whisker lines. The plot is also known as box and whisker plots. Okay, so what does this box represent? So this will be Q1 or the 25th percentile. Okay, this is Q3 or the 75th percentile. Okay, and you have the 50th percentile or Q2 or the median here in the middle. Okay, and this distance is known as interquartile range or interquartile range also. Okay, quartile and quantile, they refer to the same thing. So this is your interquartile range, which has 50% of the data. So 50% of your data lies in this box and the 50% outside it. Okay, now what is this distance? What is this distance? Now this value is Q1. Yeah, this distance is 1.5 times IQR. Exactly, Lalitya. Similarly, this distance is also 1.5 times IQR. Okay, now if we have to come to this, what is this value? If you want to know what is this value, so Q1, Q2, Q3 we can easily calculate. So in R we used a formula quantile. Remember, we used the formula quantile. Then whatever variable you want to find, you give that variable, and whichever quantile you want to find. Let's say if you want to find Q1, you give 0.25. That means 25th percentile you want to find. It will give you the answer. Okay, but let's say we want to find the value of the variable here. So what is this value? This is nothing but Q1 minus this distance. Okay, this is pure geometry. So this is Q1. Q1 minus this distance will give you this value. Similarly, Q3 plus this distance will give you this particular value. Okay, and whatever is outside this are outliers. Whatever is outside this range are outliers. So you can say that outliers is whatever is below Q1 minus 1.5 times IQR, or whatever is above Q3 plus 1.5 times IQR. Okay, so using this formula or using this description, you can identify outliers in your data. Okay guys, is this clear? So this was about outliers. Quantile functions we have already seen, variance, standard deviation, IQR. So I think we have done a complete review of week 1. Right guys? Getting working directory and all, it's pretty simple. So I think everybody knows that already. Okay. So any doubts from last week's class, guys? Tell me before we start with the week 2's topic. Yes, Debmita. Yes, Debmita, please write your doubt. We also saw, guys, how do you subset data? Okay, can you print multiple values using? Yes, Debmita, you can do that. So just use comma. So for example, print A comma B. Okay, I think it was comma or semicolon, I forgot. Let me just try. So print, let's say, so okay, I forgot the brackets. Okay, no, I have to first create two variables. Let's say x is equal to 1 and y is equal to, let's say, 3. Now you want to print both of them. Print x comma y. Do we use brackets while printing? Yes, we do. So guys, sometimes I would sound very stupid because I often get confused between R and Python. So print x is working. You write y. Nope, it doesn't work that way. Try with semicolon. Yeah, it works. So you separate it by a semicolon. Okay, see, it gave both. Okay, so guys, I often get confused between R and Python. So sometimes I would make very small mistakes which would seem pretty amusing to you, but please ignore those. Okay, because I take R and Python classes parallelly. So on the same day I have R classes as well as Python classes, so I often get confused between the two. So but once or twice if I make the mistake, I understand what is the correct syntax, but that is okay, I guess. It is okay, in fact, not I guess, it is okay. So far I have done good in both. Okay, so don't worry about that. It's okay to get confused. Anyways, we have Google at office, right? Okay, so let's come back. Okay, so one thing I missed during the revision part is how do you subset a variable. So let's say you have a vector, let's say 1, 11, 91, 50. Okay, and now you want to find out which of these values. So this might be a very long vector. Okay, this might be a very long vector with, let's say, hundreds of elements. Okay, with hundreds of elements, or imagine this vector to be the salaries of all individuals in Bangalore. So you might have around lakhs of people, right? So this vector might have lakh elements. So how do you find, now you want to find how many people are earning, let's say, above 20 lakhs. So who are those guys who are earning above 20 lakhs? You want to find them. So how will you find them? You can just write x is greater than 20. So if you write x is greater than 20, so Nijaguna, this might answer your question that you asked. Okay, if you just write x is greater than 20, you will get a series of true and false. So it will check for every individual element, is it greater than 20. So for example, element number 1, is it greater than 20? No, so you will get a false. Element number 2, is it greater than 20? No, so it is false. Element 3, yes, so you will get a true. Element 4, it's a true. So you will get true and false. Okay, but let's say you don't want this as the output. You want the actual values of the salaries. You want the actual values. So for that, what will you do? Yeah, Disha, you are almost right, but you will not have the first bracket. You will have the second brackets. Okay, the third bracket, sorry. You will have the square brackets, not the first bracket. Okay, so you will just have the same thing, but you will have it inside bracket and you will write x here. Okay, so this is equivalent to writing x false false true true. So what it will do is basically it will only print the true ones, it will not print the false ones. So what is the true? The third one. So 91 and 50, you will get that as the output. Okay, so Nijaguna, I think this is what you have asked, right? So you'll have to do this, you'll have to do this thing to get the answer. Okay, and you can give multiple conditions also. So you can give one condition here, you can use and give multiple conditions. You can also use or. So this pipe operator is or, ampersand is and. You can do this. Okay, so this is if you have to subset the variable. Now let's say if you have to find how many people are earning above 20, if you have to give a count of it, so how will you do? Can somebody guess, or at least try to guess? Let's say I have a very long vector. Imagine this vector. Imagine this vector. I need to find how many people are earning above 20. So I know the answer, it's 2. But how will I do that in R? No, Mrityunjay. Length of x will give you 4. I don't want the length of everybody. I want just the length of those who are earning greater than 20. Sum of x will give me the total salary. Vagish. Sum of x will give me just 11 plus 1 plus 91 plus 50. Okay. Okay, length of x new. And what is x new? Mrityunjay, x underscore new, what is that? Count. Okay, yeah, so Mrityunjay, he is right. Yes, exactly. So you can create x underscore new is equal to x and x greater than 20. Okay, and so this, what will be this? This will be just 91 and 50. You can check the length of x underscore new. Okay, or the other way to do this, this is okay, this is perfectly fine. Okay, but the other way to do this is you can just write x is greater than 20. Okay, so the output of this is false false true true. Okay, we know that false means 0 and true means 1. Okay, everybody knows that. You can just take a sum of it. If you take a sum of it, what will you get? 1 plus 1 2, you will get 2. So you don't have to create this new variable directly. You can do that using the sum function also, you can do that. Okay guys, is this clear? Or this is also fine, both will work. Did you understand guys, everybody? Okay, so this is, we are done with the revision for last week's class, we spent almost an hour revising, but that is okay. We are at the beginning of the class, so it's okay to go slow. So let me just save this file and create a new file now, and we'll start with today's topics. Okay, so as we did it in the last class, we won't be devoting the entire class on R or on statistics. We will keep a mixture of the two so that the class is interesting. Okay, so first let us spend some time on R, and then we will spend some time learning some other concepts of statistics. So let's study another data type now, which is called lists. Okay, so this will be another data type, your third data type of R. So don't worry, we will just have another one more. Fourth will be data frame, and this is the real data structure of R. Okay, this gives R, or even Python, this gives the power. So we are slowly coming to that. Okay, so let's see what is a list now. Now, so far we have seen matrices, we have seen vectors. Both of them used to have the same data type, right guys? Both of them stored the same data type. Lists can have multiple data types. Lists can have multiple data types. Okay, so how do you create a list? You create a list by using the list function. Very easy to remember. You create a list by using the list function. So let's say x is equal to list. Okay, and let's say you decide, you give the values that you want to have in your list. Okay, so let's say I will give a is equal to, let's say, 1 9 11. Okay, and then I can write b is equal to, let's say, apple ball. Okay, so this is a list. This is a list now. Let's go to R and do that directly instead of writing here. So I can create a list by the keyword list. Then I can write, let's say, 1 2 3. Let me write another one. B is equal to, let's say, okay. So I have created a list which has, so this list has two vectors. If you see, it has a vector called A and it has another vector called B. If I check the class of the list, class of X, it will show me it's a list. Okay, now let us print the list and see what we get. If you print the list, this is what I'm getting. Okay, see, I'm getting 1 2 3 and I'm getting Bangalore and New Delhi. Okay, so this is the list I'm getting. Okay, so you can have different data types. So these are numbers, numericals. This is a character. So we can have multiple data types in the same variable. Okay guys, now let us see how do we index the list. So let's see how do we index in a list. Okay, and always remember, a list is a collection of vectors. So let me write it down. List is a collection of vectors. So the vectors may be of different data types. Okay, so this is a vector which is numerical, this is a vector which has characters. Okay, so that is why we can have multiple data types in a list, but you cannot have a mixture here because this is a vector. Similarly, this is a vector, so you cannot have, let's say I cannot write within quotation a here. That will not work. Okay, because this is a vector. So the same rules of vectors apply, that a vector cannot have two data types. Okay, so if I run this, I will get this as the output. It has converted everything to a vector. Are you getting the point, guys? It has converted everything to a vector if I write a character here. So all these others will also be converted to character. So the same rules of vector applies. Okay, but as a whole the list can have multiple data types. So it has one numerical, one character. Okay, now let's see indexing in a list. How do we index in a list? Let's say I want to access New Delhi. How do I access that? So always remember, in a list we use double square brackets. Okay, we use double square brackets. In vectors and in matrices we used a single square bracket. In a list we will use double square bracket. Okay, so that means x double square bracket 1. What will this give me? This will give me the first vector. This is a vector, it will give me the first vector. Similarly, x double square bracket 2. This will give me the second vector. So see, the first output is giving me 1 2 3. The second is giving me Bangalore and New Delhi. Okay, and if I want to access any individual item, let's say I want to access New Delhi now. Now how do I access New Delhi? If I have to access New Delhi, so New Delhi is in second vector and second element. So I can write x double square brackets 2. So this will give me both Bangalore and Delhi. I want just Delhi, so I will give 2. Now this is my vector. This is a normal vector. So for a normal vector, how do you get the second element? You just use a single square bracket. So I will use the single square bracket and that will give me the output as New Delhi. Is this clear, guys? Okay, so the list will give you A 1 9 11. Okay, and it will give you apple and ball. Okay, now this is a vector, this is also a vector, and let's say the list is x. Now if you write x double square brackets 1, you get this vector as the output. Okay, and if you have to access any individual item in that vector, you already know this is a vector. Now to access any individual item in that vector, you just use a single square bracket. So now you will not use a double square bracket again. Double square bracket is just to go inside the list, but after that you have individual vectors and you have already learned how to access vectors. So you will use single square brackets now. So 1 2 3, whatever you want. If you give this, you will get 1 as the output. Okay, now single square brackets also works in a list. Okay, single square brackets will also work. So even if I had given x of 1, it would give me the same output. Okay, even if I give 1, it would give me the same output. So x1 of 1 will give me, but you will not be able to access the individual vector. So see the difference. I wrote x1 of 1, it is still giving me the same. So I will not be able to go inside individual vectors if I use a single square bracket. So for that I will have to use a double square brackets. So 2 will give me Bangalore and New Delhi, but if I have to go inside that, it won't go inside that. Okay, it won't go inside that. So just remember, always use double square brackets in a list. If you have to go one level inside a list, always use double square brackets. Okay, so Suraj has asked a question. Let us try. So x1 1 1. So it will still give you the same because x1 gives you the same. So it is similar to writing x1. So both will give you the same output. This and this are same basically. So this is useless. It is not even giving you anything. Okay. So even I am not sure why do they have that syntax. That is probably they should not have had. Because if they are asking us to use double square bracket, it should only be double square bracket. Single square bracket should give us an error. But it doesn't. So don't worry about it a lot. Just remember whenever it's a list, we use double square brackets. And actually in the industry we never use a list. You will never be using a list. The only place where this information is necessary is because the output of some functions will be as a list. So we will see later in some assignments I will give you this problem. Some functions will give a list as an output. So if you have to access the output of that list, you will have to use double square brackets. So that is why this much information is required, but nothing beyond that. Okay, you don't need anything beyond this. So this is all about list. And this A and B that you saw, those were the row names of the list. Okay, these are the row names. So you can change the names also. These are the names of the list. Okay, so you can also change the names. So you can give some new names to the list. So I gave A and B. Let's say I'll give X and Y. So now the names has been changed. Now if I print the list, I will get X and Y instead of A and B. So I changed the names of the list. Okay, so these A and B that you see are names of the individual vectors in the list. You can change them also if you want. Clear, guys? Is it clear, guys? Anybody who is attending the session from a mobile, using a mobile? Anybody? Okay, so is it working fine in the mobile as well? Okay, so are you using broadband or are you using your telecom data? Oh, is it working fine on mobile data also? Oh, that is amazing. I didn't know that. Okay, great. This is good. So good, guys. So you can attend the meeting even on the go. So you are in a bus, you are in a train, you can attend the meeting. That is great. So good. I'm happy that whatever I have paid a lot, by the way, for this software. Almost a lakh I have paid for this software. So I'm happy that it works fine. I never tried it on mobile data. And I guess you guys are using the app, right? If you use the app, it will consume, the experience will be even better, I guess. So guys, please download the app. There's a go to training app on Play Store. Use that app to attend the meetings. Okay, now let's start with the next data type, which is data frames. So we are coming to the final data type which we'll be using almost all the time, which is data frames. Okay, so the fourth data type is data frames. These are very important. Okay, so what is a data frame? Let's first understand, and then we will dive in our. So a data frame is just a SQL table. So for people who know SQL, it is a SQL table, or for people who use Excel spreadsheets, it is a Excel table. So what is a SQL table? In a SQL table, you will have columns and rows, right? You will have columns and rows in your SQL table. Now each column will have only one single data type that holds for a SQL as well as for a data frame. So if you have column number 1, it will always be, if it is an integer, it will always be an integer. You will always have all these values will be integer. You will not have a character here if it is of type integer. Similarly, if the second column is of type, let's say, character, all values will be strings in that column. You will not have a mixture. So you can say in a way that this is a vector. It is a collection of vectors, just like a list. Just like a list, data frame also is a collection of vector. Collection of vectors where each column is a vector. Okay guys, each column is a vector. So this is all about data frames, at least the theory of data frames. Now let us see, let us try to create data frames in R now. Okay, similarly in Excel also. So each of these columns, you might have a name for these columns. That is how you usually store, right? So for example, a company might have an employee data, an employee table, or an employee data frame, which might be, let's say the first column is employee number, then employee name, okay, then employee's unit, which unit does he work, employee's designation, employee's income, and so on. So this is a typical table which most of the companies have. Employee numbers might be a number, a 6-digit or a 7-digit number. Employee's name will be a character, the employee's name. Employee's unit again will be a character. Okay, employee's age will be again a number again. Employee's income will be again a number. So you will have a table which has a few columns as numbers, a few columns as text, and so on. Okay, so that is about data frames. And by the way guys, a list can have a list inside itself also. Okay, so we have two vectors here, right? You might have another list also as the third element. The third element might be a list also, so you can have a nested list also. Okay, but I'm not going into that much depth because we are not software engineers, so we don't have to practice all of that. Okay, you will rarely be using all that stuff. So we have lots of other things to worry and give our time to, instead of worrying about these small software problems. Okay, so this is what probably a IT engineer, a software engineer who wants to master a language will learn. But we will only learn things which will help us in our machine learning. So these things will not help us. Okay, so maybe in the assignment I will try to include one such example where you will have a nested list and I'll ask you to do something. Okay, now let us go and create data frames in R. So first let me create some variables. So let's say I create a vector called country, and I give some names. Okay, so this is a vector. I create another vector called GDP. Let me give some numbers. So I'm not sure of the GDP, but let me give some numbers. So this is the GDP, and population, let's say okay, this is the population. Now we will create a data frame using all the three vectors. So we discussed already that data frame is nothing but a collection of vectors. So we will try to create a data frame which has these three vectors as individual columns. Okay, so let me call this data frame, let me call it df. Okay, so df is, I will write data.frame. See, I'm using the IntelliSense of R. I'm using data.frame. I'll press tab to get that, and then I will pass all the individual vectors as a vector. GDP. Again, I'm using the IntelliSense of R. So this is what I do, and next I can print my data frame. So when I print my data frame, oh, it took it as a vector. Just a minute, I think this is not required. Okay, yeah. So I will just pass all the three vectors that I want as individual columns. Okay, using data.frame function. So data.frame, and I will pass all the three vectors as input to that function. Next, when I print that function, I will have this data frame ready. And if I check the class of this, it is a data.frame. Okay, so this is how you create a data frame. Okay guys, do you understand? Okay, now let us see how do we access individual items in a data frame. So indexing in a data frame. Okay, this is also very important. We do a lot of, so before we apply any machine learning on a data, before we do any machine learning, we have to clean the data. So the data always, almost always the data comes in a very dirty format. Okay, so we always have to clean the data. So while cleaning, your coding skills are tested. How good of a coder you are, that is tested while cleaning the data. Because in the machine learning portion, not a lot of coding is required. The code there is pretty straightforward. But if you have to clean the data, if you have to do some transformations in the data, if you have to aggregate the data, if you have to merge different tables and get data into a different format, for that you need a lot of coding skills. Okay, so that is why if you are a good coder, it will always help you in your career as a data scientist. But even if you are not a good coder, you can always focus on the machine learning part and yet be good. So data cleaning is, for example, missing values. So later we will see, Lalitya, cleaning data means, let's say your data is very dirty. You have a lot of outliers in your data. And as I told you, outliers might badly influence your models. So you'll have to get rid of that outlier. So that is one way of cleaning, removing outliers from your data. Or you might have a lot of missing values in your data. So missing values also are not good for models, which we will see later in a detailed discussion. But for now, missing values, outliers in your data, those are all things which require cleaning. You'll have to fill the missing values, you'll have to remove the outliers and give some appropriate values, and so on. Only then your machine learning model will be good. So all this cleaning that is done beforehand requires a lot of coding skills. Okay, don't worry, we will see a lot of that as we proceed. So I have a lot of assignments which I'll be giving you where you will have to do a lot of cleaning. And honestly, almost 80% time of almost 80% time of a data scientist job goes into data cleaning, and only 20% goes into model building. Okay, because the cleaning eventually helps you in your model building. If you have cleaned your data well, your model will also be good and you will get a better output. But if your data is not good, no matter how good a model you apply, it will not give you a good output. Okay, now let's see how do we index a data frame. So I will write data frame. Now if you have to access individual columns, let's say I want to access the first column. Okay, So how can you do that? If you have to access the first column, same as in matrix, you will do data frame square brackets and you will write 1 here. Okay, this will give you the first column. So why did I write it like this? I left a blank here because I wanted all the rows. I wanted India, I wanted USA, I wanted China. That is why I left this blank. Same way as you would do in a matrix. Okay guys, are you following? To get all rows and first column. Okay. Similarly, I can also write data frame dollar. So the moment I write dollar, I get all the 3 options. You see, Ars IntelliSense is giving me all the 3 options. Whichever option you want, you select and you just press Control Enter. This will also give you the same result. So you can access columns using dollar notation also. Okay, both will work. You can either access it using the serial number of the columns, or you can access using the name of the column. Okay, so why do we have these 2 ways of doing the same thing? See, you might have hundreds of columns. Okay, you might have hundreds of columns. Now let's say if somebody wants, using this approach, if somebody wants to access a column which is somewhere in the middle. So if that column is somewhere in the middle, it will be a big pain if you have to go and count the serial number of that column. Okay, you'll have to go and count the serial number of that column, that okay, the serial number is 44, then you will write 44 here and you will get the output. So it is very painful. So you have this other method also where you can just use dollar and use the IntelliSense of R. Okay, so not knowing the serial number also, you can access the individual column. So that is about accessing individual columns in your data. Okay, we have a few questions. Yes, Nijaguna, I will come to that levels. Jagdish, the missing is missing from view. Which one? The console. You're not able to see the console. Okay. Are you using mobile? Guys, are you able to see the console? This portion which I have highlighted right now. Others are able to see. Jagdish. In your R studio. Okay, okay. In your R studio. Okay. So just run any line. So your console might have gone like this. It might have come down. So just pull this. Just pull this above, or run any line of code. Run any dummy line of code, it will automatically come up. Okay, just run 1 plus 1 and press Control Enter. Then the console will come up automatically. Are you sure it's the console that you're not able to see, or you're not able to see the file? You only see the console. If you only see the console and nothing else, then you'll have to go and create a new file, new script file. So what I have here is a script file, and this is the console. So if you don't create the script file, you will have one big console. Okay, so you create a script file from here. No, just run any line of code, Jagdish. Just run 1 plus 1, press Control Enter, the console will automatically come up. So see, I think you might be looking at this right now. So if you write 1 plus 1, Control Enter, the console will automatically come up. Okay, you might have dragged it to the bottom. Or you can go to View. I'm not sure if we have console here. You can press Control 2 also. Press Control 2. Yeah, press Control 2, it will work. Okay, okay. Okay guys, so we now Nijaguna asked me what is this levels. Okay, what is this levels that we are seeing in the output? So the moment I print control, I am seeing levels. So this has something to do with, okay, so whenever you give a categorical variable to a data frame, Okay, so listen this carefully, guys. Whenever you give a categorical variable to a data frame, it basically freezes the categories, the different unique categories. So levels are nothing but the unique values in your data. Okay, the unique values in your data. So it freezes the unique characters that you have in your data and it calls it levels. Okay, so even if I had multiple values of the same name, so let's say I have two India here, I might have one more India. Okay, so if I have two India, let's say I'll have to give some number here. So even if I do that, I will still have the same levels. So if I run this, you see the levels is still the same. Though I have two values of India, my level is still China, India and USA. Because it is levels is the unique values. The unique values in your categorical variable. The unique values in your character variable. Okay. Nijaguna, did I answer your question? We will come to that. So there is a reason why we get that as a level. Okay. That we'll study that in machine learning part. The unique values, Suraj, the unique values. The unique values of your character variable. So levels is unique values of the, let me write string, unique values of the string variables. Okay. Yeah, even if India has two values, still the unique will be India once only, right? So you will still see, no, level is only for character variables, not for numerical variables, Suraj. So level will, you will not get levels for GDP. So for example, if I write DF dollar GDP, I won't get levels. I will just get the values. Level is only for string variables. Yes, it is case sensitive. Okay. It is only for string variables, not not for numerical variables. Okay. So that is about selecting any particular column. Now what if you want to select rows? No, it is case sensitive, Niranjan. So then you will have two India, one in caps and one without caps. Okay. Yes, it will consider that as a new level. It is case sensitive. R is case sensitive. Okay. So play around with these. Okay. You can do a lot of experiment with these and learn. Of course, I cannot show everything in a small session like this, but always play around with this. That is how you learn. Now let's see if I want to capture a particular value. You can also do that. So the way you filter in a matrix, the way you do indexing in a matrix, you can do the same in a data frame also. So I have given data frame 2 3. 2 means second row, 3 means the third column. So I am getting 60 as the output. So all these things you can do in a data frame also. Okay. Similarly, I can write data frame second and I can leave it blank. That means I want all the values in the second row. So I'm getting USA 70 and 60. Okay guys. So all these operations you can do. So using matrix like indexing in data frame also works. Okay. Now let us see how do we combine two data frames. How do we combine two data frames? Let's see that. So I have created this data frame called DF. So my DF looks like this. Now let me create another data frame called df2. I will create another data frame called df2, and this should have the same columns as before. So let's say I have some new countries. Let's say it's Australia. Let's say it's Brazil. Let's say it's UK. So Australia is, let's say, 10. Brazil is, let's say, 12. UK is, let's say, 18. Okay, so let's say these are some values, and I'll create a new data frame called df2, which will be data.frame, and I will give the same value: country, GDP, and population. So this is my data frame 2. Okay, so this is my first data frame, and this is my data frame 2. Okay, they have the same columns. So how do I merge the two data frames together? So merging two data frames with same column. Okay, so for that I can use a function called Rbind. So how do I do that? So I create, let's say, all data frame. This is the new data frame which will have both combined, and I will use Rbind. Okay, Rbind means row bind. It will just merge the rows together. Okay, and I will give as input the two data frames. So my first data frame is df, my second data frame is df2. So when I do this, and if I see my all data frame, it has combined both. Okay, it has combined both the data frames together. Is it clear, guys? Guys, is it clear? So this is just used to merge two data frames. So always remember, we can only use Rbind when the column names is same. If the column names in any of the data frame was different, it will not merge. It will throw error. So let's say, for example, I had population 2 here instead of population. No, Mrityunjay, it will not get confused. It is just merging the rows together. Okay, it will not get confused. So Rbind, what it will do is, let me show you here. So let's say your columns are A, B, C. You have some values here. Okay, so this is your first data frame. Similarly, you have your second data frame. Yeah, that's what I'm telling. So you have your second data frame A, B, and C. You have some other values here. So the moment you write Rbind df1, df2, what it will do is it will just take this data frame and it will put it at the bottom of the other data frame. It will bring it here. Done. So it will create a new data frame where it will already have the values from df1. It will take this and it will just put it below that, under the same column. Okay. No, there will be two entries. So if there are duplicates, Jagdish, there will be two entries. It will not throw error. Okay. No, Lalitya, while creating df2, it will just overwrite. I have not given the same name, right? This is df2. Okay, this is df2. This is df1. They are different data frames. Now, whatever columns you had here, A, B, and C, those columns will be overwritten. Now A will no longer have these. A will have these new values. Similarly, B will have these new values. Okay. Now what happens if you have different column names? Let's say I have population 2 instead of population. So in df I have country, GDP and population. But let's say in df2 let's say I have population 2. Okay, now I have different column names. Let's see what happens. So df2 has this as the column and df has this as the column. So the column name is different. Now let me try to merge. Okay, I'll merge df and df2. See, what do I get? Error in match.names. Names do not match with previous names. So R is exactly telling us the error that names do not match. If the names are not matching, R will not be able to merge. Okay, because one has population 2, one has population. So R cannot merge these two data frames together. Okay, guys. So this is about merging two data frames. Okay. So create an example like this, practice as much as you want. You can try different things. So I have not tried a lot of things here. So whatever doubts you are having in your mind, it's best way to learn is create a data frame and start doing things. Play around with it. Okay. Play around with it. Whatever doubts you are having, whatever you want to do, just play around with this. And that is how you will learn the best. Okay. So this was the rbind function. Okay. Now there is another function called merging data frames by columns. Okay, so can anybody guess what the function will be? Yes, exactly. So this function will be cbind. So Niranjan has asked, is it not possible to merge providing an implicit column names like mapping this column? Niranjan, I believe you are asking what is the left join, the right join that we do in SQL, right? Are you asking that? So where you have one foreign key and based on that foreign key you merge. Are you asking that? Yeah, so we will come to that later. So that will be a topic of tomorrow or the next class where we do a left join, we do a right join. So all of these things can also be done in R and very easily it can be done the same way you do in Python. The function is also the same, merge function. Okay, we will come to that. So I'm going slowly. I'm going very slow in this course. Okay, so that you understand everything. You don't miss even a single small piece also you should not miss, because this will form the foundation of the course. Okay, this will help you later when we are dealing with advanced topics. Okay, so we will come to that where we'll be doing merging of two different tables together based on one particular column. So right now we are doing a simple merging, just bringing one on top of the other. Okay, or in Cbind bringing one at the side of the other, adjacent to the other. So let's see what is Cbind. So let's see what is data frame. So this is our data frame. Now let's say I have another column called, let's say, what column should I have? Let's say you have a column called, let's say, ranking. You have a column called ranking, and for India, USA, China, the ranking is, I'll place India at the first, China at the end, because I don't like China. We have had a war with China in the past and we were on the brink of war with China some time ago. Okay, so I don't like China. I'll place it at number 3. So just let's give this ranking. Now I want to include this ranking here. So besides population, I want to have another column which will give me the rankings. Okay, so how can I do that? I can create, let's say, data frame new. I can use the function cbind, the original data frame, and first I'll have to convert this to a data frame. So right now ranking is a vector. I'll have to convert this vector to a data frame. So let me call it a temporary data frame. Temp.df is equal to data.frame Okay, and I will give ranking. Now it's a data frame. I will use temp underscore df. So if I use this, and now if I print this, I will have ranking also included in my data frame. In my new data frame, I'll have ranking also included in the same order in which I give. Okay, in the same order. So 1, 2, and 3. Okay, so this is the application of cbind function. So rbind and cbind. So rbind, just remember, very easy to remember. Don't get confused between the two. Okay, so rbind means one on top of the other. Okay, this way it will merge based on the rows. Okay, it is merging the rows together. And cbind, it will merge the columns together, so one besides the other, so adjacent to each other, so it is merging the columns together. Okay, so this is rbind, this is cbind. Both has to be a data frame. Okay, this also should be a data frame, this also should be a data frame. Similarly, this should be a data frame, this should be a data frame. Okay, is this clear, guys? Okay, great. So now, so this is this, so there are a lot of things that we can still discuss about data frames. So for example, let's say I want to know which are the countries which has a population greater than, let's say, greater than 100. Okay, so I can do a lot of operations on my data frame. So I will write data frame, then I will write data frame dollar population is greater than, let's say, 100. So I want to know which are the countries which has a population greater than 100. So I will do this, and I will get only those two countries as output which has a population greater than 100. Okay, so how did I do this? I just wrote the condition here and I gave a comma here. Why did I give a comma? Because I wanted all the columns. Okay, I wanted all the columns, so I gave a comma. In a vector, what you do is you just give this, you don't give this comma, because vector is one dimension. Okay, but here it is a two-dimensional structure. Data frame is two dimension, so you will always have to give two dimension. So whichever column you want, you can put here. If you want all the columns, just give a space. Okay, and whatever I want to do, okay, let's say, let me write down the question. Greater than 100 population. So this is what I will do. So get all country which has greater than 100 population. This is how you will do it. Okay, if I want just the country names, if I want just the country names, not all columns, then how would I do it? I will just write data frame dollar population greater than 100, and instead of leaving it blank, I will just write in quotation, I will write population. In quotation, I'll give population. Okay, this will give me the population, but I want only the name of the country, right? So I will write COUNTRY. This will give me only the name of the country, which is India and China. Okay, or the same operation I could have done using the index of the column also. So I know the index of country is 1, so I can write 1 also. This will also give me the same output. Okay, or there is another way to do it. I can do the filtering here itself and then give the condition. So I can write this entire thing here. This will also give me the same output. So guys, do you understand these three lines? Very important lines. Okay, make sure you understand all the three. Tell me if you have any doubts. Just go through these three codes for a moment and tell me if you do not understand. I'm sure you might face some difficulty because this is something like trickier, but tell me which one do you not understand. No, Vagisha, it is correct. You see, it is giving me the output. No, it is giving me two outputs. The level is the same. The level is same for everybody. Level is just the unique values. My output is India and China. This is not my output. This is not my output. My output is this. This is just a way of showing. Don't consider this as the output. The output is the first line. Okay. Okay. So let me explain what I have done here. Okay. Let me explain that here. So let's say I had this data. So I had country, I had GDP, and I had population. Okay. Country, let's say India. This is USA. This is China. GDP, let's say 80. This is 60. This is 45. Population is 130, 70, and this is 145. Okay. Let's say this is our data frame DF. Now I want only those country which has greater than 100 population. Okay. So now this is a two-dimensional structure. We all know that. We can clearly see there are rows and columns. So it is a two-dimensional structure. Okay. This is two dimension. Now how can we get this value out? How can we do that? So what we will do is there are multiple ways of doing it. Okay. So in a vector you saw we used to write x, and if you have to subset the vector you used to write x is greater than some number. Okay. So the same concept we will use and we will take it to two dimension. So this was in one dimension because a vector is a one dimensional structure. Now we have to take it in two dimension. So what do I want? I want basically this row and this row. I don't want this row. So that filtering that I have to do, this condition that I have to apply, that population is greater than 100, I have to apply this condition on the row, not on the column. On this particular column I have to apply the condition, but on the rows I have to apply the condition. Okay. So remember, when you do something like this in Excel, what do you do? So when you have to do something like this in Excel, for example, so what do? You basically apply the condition on the rows, right? So this is like applying the condition on the rows, not on the columns. You have selected one column, but you are applying the condition on the rows. These are different rows. You are applying the condition on the rows. Let's say duration hours. You are applying the condition on the rows, not on the columns. You have just selected one column and applying the condition along all the rows. Okay. So on a similar concept, you will apply this condition on the rows. That means if this is your data frame and you have your rows here, you have your columns here, that condition should come here and not here. Okay. Here you will only select the columns which you want to print, but your condition will come here at this place before comma. Are you getting it, guys? Okay. So let's do that. Now if I write data frame and I write that condition, so I cannot directly write population is greater than 100 because R doesn't know what is population. R cannot access the population which is inside a data frame. So to access a population inside a data frame, I'll have to use data frame $population. Only then I will be able to access. Without that I cannot access, right guys? Without that I will not be able to access. I can only access it by writing data frame $population. If I just write population, R will think this is a vector and it might throw me error. Okay. So I'll have to write the full structure of accessing this. And then if I leave this blank, it means that I want all the three columns. So R will print me country, GDP as well as population for all the rows where this condition is true. So that means it will print me India and it will print me China. Okay, that's what it will do. So this is one way of doing it. Now the other way is, let's say I want, now I can write data frame. Now let's say I want just the name of the country. I want India and China as the output. So what can I do? I will do the same thing, data frame dollar population greater than 100, and I will write which column do I want. So I want just country. So I will write country, and this will give me India and China. Okay, don't worry about the levels. That is just our way of showing. That is not taken as output. This is just for visual purpose. The output is this. Okay, or the same thing I can do. I have written country here, so I might have even used the index of the column. So index is 1, this is true, this is 3. So I could have written the same thing as df dollar population greater than 100, and I could have written 1 here also. 1 means the first column. So this will also give me India and China. Okay, so this is a data frame where I have 2 dimensions. So I'm using a comma here. Now what if I can reduce this to a vector? Okay, how can I reduce this to a vector now? I can reduce this to a vector. Now this is 2 dimension data frame. That is why I have a comma here, because this is in 2 dimension. Now if I write data frame dollar country, this is no longer 2 dimension, right guys? Data frame dollar country is only 1 dimension. It is a vector. Guys, is it not audible? Am I audible? Lalita, I am audible to everybody else. Okay. Maybe your internet issue. Guys, you might be able to use the mobile internet data, but it's always preferable to use broadband if you have. Okay, because the mobile internet is not very efficient. It is not very reliable. So it might come sometimes be at good speed, sometimes at not so good speed. So maybe because of that, you might have, the quality will come down if you're using mobile internet. So if you have access to broadband, please use broadband. Don't use mobile. Okay, because I'm using VoIP, right? So VoIP on a mobile network might not be very good. Okay, so now what I can do is, now this df was 2 dimension. That is why I was giving 2 inputs. Similarly, this df was 2 dimension, so I was using the comma and giving 2 inputs. But now I have no longer, I no longer have it as 2 dimension. I have already filtered data frame dollar country. That means I just have 1 dimension now. This is just a vector. It is not a 2 dimension. Okay, now I can apply the same condition here. So data frame dollar country, still not audible. Okay, I'm not sure. uh, okay, I'm audible now. Okay, okay, so now what are you doing? You are basically filtering out the data frame and selecting 1 dimension. So you have already selected 1 dimension, so you don't have to use the comma now. You just have to apply the condition. So I will apply data frame dollar population is greater than 100. I don't have to give a comma. It will print me only the country column. It will not print me all the columns. Okay, because I am in 1 dimension now. I am no longer in 2 dimension. So no, not required to give 2 inputs. Just 1 input. The condition is enough. Okay, guys, is this clear? Are these 3 things clear? Okay, so please watch the recordings. Okay, please watch the recordings later whenever you have time. So I'll share the recordings by the evening. So maybe tomorrow morning before the class starts, you'll have enough time in the morning. We'll have the class at the same time, maybe 1 o'clock or 1:30. So you'll have enough time. Please revise it once, or maybe later during the week. I think most of you have a long weekend. today, right? This is a long weekend for you, so please make sure you utilize this weekend well. Okay, and this might be, if you are planning to take this course and planning to take your journey into data science seriously, this might be probably your last weekend. So from the coming weekends you'll have to work hard. Okay, you'll have to work very hard from the coming weekends for the next 2 to 3 months. Okay, if you are planning to take data science seriously. Okay, so this is all I had for today's R part. So now we can start with the statistics portion. Okay, so don't worry about these guys. These are things which are pretty new to you. So as you go on practicing the hands-on, you will get it. It's very easy. Okay, I'll give you some assignment on this so that you get to practice. Okay, so let's do one thing. Let's take a break, and after the break we will start with the statistics part. So we will spend maybe around 40 minutes doing the statistics. Then again we will revise everything that was covered today, and we will close for today. Okay guys, shall we take a break? Maybe 10 minutes break. So let's take a 10 minutes break. Let's be back by 3:15. Okay, so let me write it down here. Okay, so let's resume at 3:15. I'll see you then guys. Okay, so let's resume. So the R part is over for today. We saw we saw two data types today. We saw what is a list in R. List is a collection of multiple vectors, and each vector can be of any data type. Okay, we saw how do we do indexing in a list. We use double square brackets to index the individual vectors in a list, and once we have the individual vectors, we all know how do we index within a vector. We use a single square brackets within a vector. Okay, next we saw what is a data frame. A data frame is again a collection of vectors, just like a list. It's a collection of vectors. So who can tell me what is the difference between a list and a data frame? Because both are a collection of vectors, right? And both can have individual data types. So what is the difference then between a list and a data frame? Yes guys. No Lalitya, list is also two-dimensional. We saw that, right? List is also two-dimensional. So it has 1, 2, 3, it has Bangalore, New Delhi. So for example, this list, it is two-dimension, right? This is one dimension and it is going down also. It is going horizontally as well as going vertically. Okay. Then what is the difference? It's very simple actually. If I tell you the answer, you will realize that yeah, you were missing that. Yes guys, anybody would want to make a guess? Okay, in list, row is a vector. In data frame, column is a vector, right? Okay, yeah, that's a fair point. Yes, that is correct. So in list, a row is a vector. In data frame, a column is a vector. Okay. Any other difference that you see? So you have a list and you have a data frame open in front of you. Any other difference do you see? So one Disha is right. So horizontally you should have the same data type in a list. But in a data frame, vertically you should have the same data type. And no, data frame is not a collection of lists. Yeah, you can say that as well. The data frame is a collection of lists. But that wouldn't be true for all cases. Okay, so in this case it is true, but it wouldn't be true for all cases. So the difference that I was looking for is, in a list you can have any number of elements. Okay, so for example, you have 3 elements here, you have 2 elements here, but in a data frame it should be equal. A data frame should have the same number of elements in each column. It cannot be up and down. Okay, so for example, country, GDP, population, each of them has 3 values in the vector. Okay, if the values are not the same, it will throw error. So you can try that here. So let's say you create a data frame where you have different numbers. Okay, so this is where we are creating, right? So let's say I get rid of this. Oops, I delete this. Now you have a vector country. Oops. Country, which is Australia, Brazil, UK. You have a vector GDP, but it has only 2 elements, 10 and 12. And you have population, which has again 3 elements. Now I am trying to form a data frame from the 3. See, I am getting error. Error in data frame country, GDP, population. Arguments imply differing number of rows, 3 and 2. So what it is telling you, that some columns in this code that you have written, some columns has 3 rows and some columns has 2 rows. So that is why it is not able to create a data frame. But if you do this with a list, it can easily run this. A list can have different numbers. In some vector it might have 2, in some vector it might have 10. But for it to be a data frame, it must have the same numbers. So if you define a vector with 3, all the other columns in the data frame also should have 3 elements. Only then it will work. Okay, clear guys? Was that clear? Okay. And then we saw how do we do indexing in data frames. You can access individual columns in a data frame by just using $. You can use $ to access individual columns, or you can use normal indexing of a matrix. That also works in case of a data frame. Then when you have to subset a data frame, you can use this indexing to do a subsetting also. So the indexing can be used to do subsetting of a data frame also. And we have to be careful when you're doing this subsetting. It depends whether you should. So this subsets will almost always be on the rows. Okay, this condition that you applies will always be on the rows. It will never be on the columns. On the columns you will just write the column that you want to print. So here I want to print the country column, so I'm writing country here. So you can write either the name of the column or you can write the index value of that column. So country is the first column, so I wrote 1 here, and the condition I have written in the rows. Okay, the other thing you can do is, at the beginning itself you can give which column do you want. Then you will just have to write the condition inside the square brackets. You don't have to give a comma again, because you have already reduced it to 1 dimension. Okay, so that's what we saw on our part today. Now let us move to the statistics part. So we will build on the concepts that we saw in the last week. Just a minute, I'm having issues with my pen. I'm very slow. Yeah, fine now. Okay, so now let's continue with the statistics. Let us see some distributions which are very commonly used. Okay, we will talk about some distributions, some of which you might have seen in your school days, some of which you might have heard in your companies but never seen it. We will see those in details. Okay, So the first that I want to talk about is uniform distribution. Okay, uniform distribution. So anybody remembers what is a uniform distribution from your school days? So Mrityunjay says distribution with fixed intervals. Not really. Anybody else remember something? Difference between two variables is same. I think I understand what you're trying to say, but you have not put it exactly in the words that I would want to hear. Equal value of distribution. So I understand that you know it, but you're not able to tell it properly. Equal value. What is that value? No, Nijaguna. Not variables are placed in linear model. No. So it means something like this. So if I draw a histogram of that variable, okay. No, Mrityunjay. It has nothing to do with standard deviation. Okay. If I draw a uniform distribution and if I draw a histogram of that, it will be flat. It will be flat like this. It is uniform. It is not changing. Usually, whatever we saw, it was changing, right? Here, it is not changing. It is flat, aligned with slope 0. So this is uniform. That means it is not changing with respect to whatever it is. So let's say the salary, for example. Let's say I know salary is not uniformly distributed, but assume. So this is salary, let's say. So that means there are, let's say this is 10. So there are 10 individuals in Bangalore whose salary is 3. There are 10 individuals in Bangalore whose salary is 6. There are 10 individuals in Bangalore whose salary is 20. So if all those is the same throughout, so if you connect all the bars like that, so imagine there are many bars like this. When you connect all of them, it will look like a flat line. Yes, you can say the frequency is the same. So the exact answer that I was looking is the frequency remains the same. Or you could have said histogram is flat. Okay, any of these answers would have sufficed. So the frequency remains the same, it does not change. Okay, so this is a normal distribution. So for example, you can show the normal distribution with respect to, let's say, speed. So this is where you would have seen in your high school. Okay, the speed with respect to distance. This is your distance, this is your speed. Let's say you are going from Bangalore to Mysore. You are going from Bangalore to Mysore. So initially when you are in Bangalore, your speed will be very less. Your speed will be very less. As you hit the highway, you will increase your speed. Then the speed will be almost constant on the highway. And then again when you enter Mysore, you will get some traffic in the city and your speed will again come down. So this is a distribution of your speed on your way from Bangalore to Mysore, let's say. Bangalore to Mysore. Now in this portion it is uniform, I can say. Only for this portion it is uniform. For the entire distribution it is not uniform, but for this distribution it is uniform. So some midway on the highway your speed was almost the same. It was not varying. So it's a uniform distribution in this range, is what I can say. Okay? Everybody got it? What is a uniform distribution? So that's why the word uniform, because it stays uniform. It does not change. So why do we study these distributions is because they might help us in solving business problems. Okay. So for example, the number of cakes sold by a cake shop, let's say. The number of cakes sold. if you plot it on, let's say, on the weekdays. So let's say this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so let's say they sell the same number of cakes every day. So might be a coincidence, but let's say if you collect data of, let's say, 5 or 6 months, you will see that they sell the same number of cakes on all days. So that means the number of cakes sold is uniform over the weekdays. The number of cakes sold is uniform. It does not change. Okay, it will not happen that way. It is very unlikely. Probably on weekends you will have higher sales, but at least on the weekdays you can say it is almost same. It is uniform. Okay, so using this distribution we can basically solve a lot of business problems, which we will see later. Okay, guys, just give me a minute. I'm getting a call. Okay, guys, so this is a uniform distribution. We will see later how. See, the first thing that you do whenever you get a business problem is you identify the type of distribution. Okay, so let's say Infosys sales of a company, let's say Infosys sales, it varies across the months. So we try to find out what is that distribution, how does it vary, how does Infosys revenue or Infosys profits vary over the months. So that distribution is very important. Only if you identify the distribution, you can dive deeper and try to solve a business problem. Okay, so understanding the distribution is very important. So this is one of the distributions. Let's see a few more. Okay, the second type of distribution that we will see is, let's say, triangular distribution. So guys, whatever we are learning or whatever we learn in data science and analytics is very similar to what people learn in MBA. Okay, so if anyone here has done an MBA, you will be able to relate better. Not only this class, but all the upcoming classes also, especially the statistics part, because in MBA also you learn the same amount of statistics. Okay, so Radhakrishna, have you done an MBA? Okay, no, that was a yes earlier. I thought you just replied with a yes. Okay, that was an earlier yes. Okay, because I have taught a few people from, like, in my last batch I had a guy from IIM Bangalore. Okay, so he was able to relate everything. He said the same things they had covered in their MBA as well. Okay, or if you are planning to go for an MBA later in your career, you will be at an advantage when you go in your MBA. Okay, but I don't think if you are doing good in machine learning you should go for an MBA. You should not basically spend 2 years of your time in pursuing a full-time course. Those 2 years instead you can spend in learning machine learning, and you will grow equally well. Okay, okay, that's a different talk. So triangular distribution. Now what is a triangular distribution? So as the name suggests, the histogram of this distribution looks like a triangle. Okay, so I'm not saying it should be an isosceles triangle with the two angles equal. No, it can be any triangle. It can be this triangle also. Okay, and this is, we are drawing a histogram. Okay, so all these are histograms. So what is this? So this distribution only knows what is their minimum. So this is the minimum value it can take. Let's say the salary of all software professionals in Bangalore. So let's say the minimum it can go is 2 lakhs. The maximum it can go is, let's say, 80 lakhs. Okay. All other values will be in between. And these are the frequencies. Okay. So the frequency increases as you approach around 10 lakhs. After 10 lakhs, the frequency starts to decrease. And this is how it will look like actually. If you ask everybody in Bangalore, this is probably how it will look like. It will look like a triangular distribution. So we know the minimum, we know the maximum, and you know the mode of it. Okay, so then it will be called a triangular distribution. Now, for example, let's say you're trying to solve the problem, the same example, let me take the number of cakes sold by a cake shop. Okay, so the person may not remember how many cakes he sells every day. He might not keep a track of it. But let's say he remembers that the minimum cake he sells is 20 on any given day. He remembers this. So this was a day when he had a very bad day and he sold only 20 cakes. Okay, and similarly the max he sold was, let's say, 80. So one fine day he sold 80 cakes. So he remembers that, and this was not a good day for him. So this day he sold 20 cakes, the other day he sold 80 cakes, and all other days he sells somewhere in between. He doesn't remember how much on each day. So then you can draw a histogram which will look something like this. You can assume it to be a histogram of this shape, where the minimum is 20, the maximum is 80, and other days it varies something like this. Now what is this peak that you have to find? It can be a triangle like this, it can be a triangle like this, it can be like this, or anything. No, Devmita, yeah, you can say this is also a right-tailed histogram. Okay, so right-tailed and left-tailed has nothing to do with the distribution. They can come in any distribution. Okay, they can come in any distribution. Of course, not in uniform distribution. In uniform distribution, you will never have right tail or left tail because it will be constant throughout. But in triangular distribution, you can have a, so for example, this is a right tailed. Okay, this is a right tailed histogram. So right tailed has nothing to do with the distribution. It can come in any distribution. Okay, so this is a right tailed histogram. But this is triangular distribution also. Okay, did I answer your question, Debmita? Okay, so this is about triangular distribution. Okay, so sales of cake can be a triangular distribution because the person only knows the minimum and the maximum, and other than that he doesn't remember how much he sells. So the triangle can be like this, the triangle can be like this, or anything. It can take any shape in between this, but the minimum is this and maximum is this, that much we know. Okay, so any business variable can take this shape. So for example, number of mobiles sold by Flipkart on a weekend. So let's say on a Sunday. So the minimum sales of mobiles on a Sunday was, let's say, 200. Not 200. I think it will be pretty huge. Okay. Let's say 20,000. The maximum was, let's say, 80,000. And somewhere in between you might have some kind of a shape. Okay. So that might also follow a triangular distribution. Now next we will see uniform. We have already seen. Now we will see normal distribution. Okay, this is the most important. Now we will see normal distribution, also known as bell curve. Okay, so anybody has heard of these things before? Bell curve especially. You might have heard of bell curve. Yes, where have you heard of bell curve? Appraisals, yes. So we'll be talking about appraisals now. Okay, so let's see what is normal distribution, what is a bell curve. When you draw the histogram, and if you get a bell-shaped figure, okay, if you get a bell-shaped figure, this is a normal distribution, okay. This is a normal distribution. And why is this so popular? One reason is because most of the companies, they follow the normal distribution to give appraisals. The other reason is many things in nature also follow the normal distribution. Many things in nature also follow the normal distribution. So example is, let's say height of all male or female, whatever, between let's say 10 years to 15 years. If you do this, you will get a normal distribution, because some people will be shorter than the others. Similarly, some people will be taller than the others, but most people will be having the average, right? This is the average. So in this case, you will have the mean and the median around the same point. Okay, it will be almost the same. Okay, if it is a perfect normal curve, they will be exactly same. If it is a approximately normal curve, they will be almost the same. Okay, so this is your mean, this is your median, and this is the mode as well. So all the values will be at the same point. So this is your normal distribution. Now if you plot the height of any individual between a certain age group, you will find the normal distribution. If you plot the height of let's say the weight of all chicken eggs, then also you will get a normal distribution. So you will get some eggs which are very big and are thus heavier, some eggs which are small and are thus lighter. But very small eggs will be very few. The frequency will be very less. So this is frequency, remember. We are drawing a histogram. And the chicken eggs which are very heavy or which are very bigger will be very few. Most chicken eggs will have the normal standard size. So they will all fall here. Okay. And this is also used in companies' ratings. How companies do ratings is, they will give very bad rating to a few people, maybe around 5%. They'll give very bad rating and they will probably kick them out. They will give very good rating to another 5% people. They'll give very good rating, and most of the people will get the average rating. So at least in Infosys it is CRR2. Okay, you will get very few people with 1 plus or 1. Okay, and similarly very few people with 4 or 3. So something like this. Okay, that is why bell curve is so famous, and only 5% will be here. So 5 people out of 100. Similarly 5 out of 100. Now not exactly 5%, this can be 5 to 10% depending on the company, but this is how they force. And why this term has become so infamous is because not a lot of companies, but sometimes the companies, they force people. So let's say everybody performed well on a given quarter or on a given year or on a given appraisal cycle. Everybody performed well, so you will not have anybody falling in this area. So the graph will look something like this. It will not have anything here. But what the companies will do, they will force people to go there. They will pick some guys and they will forcibly put them here to finish this, to complete this bell curve. They will force people to go there. That is why this is so infamous. Okay, because sometimes forced bell curve happens. They will forcibly try to plot this by putting good people also in this range. Sorry, I took it the other way around. That never happens. Okay, the companies will never do that. It is the other way around. From here they will put it there. If your bell curve is, let's say, like this, they will take people here and put them there, so that this curve completes. Okay, now there is a equation also to this bell curve. There is some equation. Okay, so if we take this as y is equal to, there is some equation in terms of x, and the standard deviation. Okay, so to know this equation, you just know the value of x and the value of standard deviation. If you have these two variables, you can fully understand this curve. Okay, so this curve, the bell curve or the normal distribution, is a function of x. X is the variable itself and the standard deviation. Okay, so I don't remember the equation, it's a little complex. Let me just Google it quickly so that I can show you. You don't need to remember, don't worry. So normal distribution, let me go to the Wikipedia page, that should have the equation as well. So this is the equation. Okay, so it's a function of x and the standard deviation. So you can see sigma here, right? Sigma is the standard deviation. They have written the average also, but the average you can calculate from x itself. You don't need to know the average separately. So this is the equation. Okay, you have x there. So in this equation you have x and you have the standard deviation. Okay, so this is the equation. Okay guys, so don't worry, you don't have to remember the equation. R remembers it, so that's more than what we need. Okay, so this is all about your normal distribution. I forgot to tell one thing, even your uniform distribution has a equation. So what is the equation of this uniform distribution? For example, y is equal to, what should I write? What is the equation here? Yes guys, for this uniform distribution, what is the equation? Y is equal to x. No Lalitya, x is 3 here. Is y equal to 3? No. Y, x is 6 here. Is y equal to 6? No. X is 20 here. Is y equal to 20? No. Y is equal to x is a line like this. Slope is equal to 0. This line also has slope is equal to 0. This line also has slope is equal to 0. Even this line has slope is equal to 0. So can I take any line like that? Think guys, the answer is here. The answer is here. Yes, Satish, you are right, but what constant? The answer is again here. Y is equal to 10. Yes, so Nizaguna has given the answer. Y is equal to 10 is the equation of this normal distribution. You see, y is always equal to 10 here. No matter what is your x. Your x is 3, y is 10. Your x is 6, y is 10. Your x is 20, y is 10. Remember, we did this in school. Right guys, we did this in school. Y is equal to 10 is the equation of this line. The equation of this line is y is equal to 10. And that is the equation of this normal distribution, of this uniform distribution. Okay, it is not dependent on the value of x like your bell curve is. It is not dependent on anything, it is just a constant. So when you say y is equal to x, that means a line at 45 degree. Okay, this is your y is equal to x. So this is not like that. Okay, when you say y is equal to constant, or when you say slope is equal to 0, so all of these lines are having slope 0. All these lines. Any line which is parallel to your x-axis has a slope 0. But this is not just any line. This is a line which passes through this point. Y is equal to mode. Yeah, it can be mode of x, but mode of x itself is 10, right? So y is equal to 10. You can directly say instead of saying y is equal to mode of x. Okay. You can directly say y is equal to 10. Okay, Devmita? Okay. Similarly, there is an equation for triangular distribution also, which I don't remember now, and it is not required. It's a little difficult to remember. So a triangular distribution is a function of its minimum value and its maximum value. Okay, it's a function of this value and this value. A normal distribution is a function of the value x, or you can say x bar also, you can say. It's a function of x bar and the standard deviation. Okay, x bar is nothing but a function of x, so you can say any one, both will be correct. Okay, now now we will study normal distribution in details. Okay, why do we study normal distribution in details? Because later we will see a lot of statistical theorems, they are based on the normal distribution. Why are they based on normal distribution? Because a lot of things in nature and a lot of things in businesses follows a normal distribution. So for example, let's say profit of Infosys. So Infosys, sometimes Infosys will not do good, then the profits will be very small, somewhere here. Sometimes Infosys will do very good, then the profits will be here. But most of the times Infosys will do like on an average. Infosys will do on an average most of the times. So it will be somewhere here. So even the profits of any company, if you plot, it will look something like this. Okay, the percentage growth of the company, it will look something like this. So a lot of things in businesses also follows the normal distribution. This is the ideal situation to have. So most of the theorems on statistics are based on the normal distribution. Okay, so that is why we will study normal distribution in details. So this is just an introduction to normal distribution. We will study it in details now. Okay guys, is everything clear till now? Okay, so let's see. So what did we see so far about normal distribution? We saw that the normal distribution, the y of a normal distribution is a function of the mean, which is here, and the standard deviation. Okay, it is a function of the mean and the standard deviation. Okay, which has some equation also, which I don't remember. Now why is it so important? Now this is important because if we know the average of this distribution and if we know the standard deviation of this distribution, we can identify individual points in the distribution. We can identify proportion on any side. So let me give you an example. So let's say this is the average, right? So let me mark the average as x bar, and let's say standard deviation. So what the normal distribution tells me is that if you go one standard deviation on both sides of the average, okay, so that means I come here, I go here. So this is like, so this line is x bar plus 1 into sigma. This is x bar minus 1 into sigma. So what does that mean? That means I go one standard deviation on both sides of the average. So this particular area. So that means if I go between x minus 1 into sigma and x plus 1 into sigma, it tells me that I get 68% of the data. It tells me that 68% of the values lies in this area. Okay, this you can memorize basically. This is proven. Okay, that you get 68% of the area if you are within that range, and we will see what is the application of this, but this is what it means. Okay, similarly, if you go two standard deviations from the average, that means x minus 2 into sigma to x plus 2 into sigma, then you get 95.5% of the area. Okay, so this red area is 95.5%. Okay, and finally if you go 3 standard deviation from the mean, if you go 3 standard deviation from the mean, you get 99.7% of the area. So this green one is 99.7%. Okay, so this is a stats that we get from a normal distribution. Is this clear, guys? So you will basically have to memorize this. There's nothing concept here, just that if you go two standard deviation on both sides of the average, you get 95.5% of the area. Okay, okay guys. Okay, so let's see one application of this. Okay, let's see one small example. So let's say the marks scored by students in an exam. Let's say the marks scored by students in an exam is normally distributed. The average mark scored is, let's say, 60. The average mark scored by all students is 60, and the standard deviation is 10. I'm giving you these values, okay? And standard deviation can never be negative, by the way, guys. It will always be a positive quantity. Remember the formula of standard deviation, right? Xi minus x bar divided by n whole square under root. So this can never be a negative quantity. It will always be positive. And by the way, what is the standard deviation? Okay, that will come later. So the standard deviation is 10. So now my question is, how many students scored more than 90 if there were 300 students in the class? You got the question, right, guys? The marks, so I'm telling you that the marks scored by the students is normally distributed. Okay, I have to tell you this. If I don't tell you this, you cannot straight away go and use all of this. It has to follow a normal distribution. Only then you can use all of these formulas. Okay, so the marks scored by students is normally distributed. The average marks I have given you, the average marks is 60. The standard deviation is 10. Now I'm asking you, how many students scored above 90 if there were 300 students in the class? How many students scored above 90? Yes, let's see who can tell me this. So use your pen and paper and see if you can come up with an answer. So Satisha says 120. Let's see what others get. Okay, Jagdish got 15. Jagdish, maybe you can reply to everybody. I think you are by mistake replying only to me. Maybe you can change that to everyone and reply to everybody. Others will not be able to see otherwise. Okay. Yeah. So Jagdish is getting 15. Satisha got 120. What about the others, guys? It's very easy. Just use these proportions. So Satisha, Jagdish, you might want to check your answers because you are getting different answers. So either one of you is wrong or both of you is wrong. But both cannot be correct, right? So maybe you would want to check your answers. Yes, guys. Why is it taking so long? Are you waiting for somebody else to give an answer? I want everybody to give an answer. And I have told before, whenever you attend the class, always have pen and paper ready. Okay? Because we do a lot of maths in data science. Okay? So always have a pen and paper handy. You will need them. That will help you understand better. Okay, so let's try to do that. So what have I told? I have told you that the average is 60 and the standard deviation is 10. So if I draw a normal distribution for this, let me draw a normal distribution. I have told you that the average is 60. So the average is somewhere here, it's 60, and I have told you that the standard deviation is 10. Okay, so sigma is 10. And I'm telling you that I'm asking you the question, how many students scored above 90? Okay, 90 means I have to go 60, 70, 80 and 90. So somewhere here, right guys? 90 is somewhere here. And how many standard deviation away is that? Is that one standard deviation away? No. Is that two standard deviation away? No. It is three standard deviation away. Right? Yes, Mrityunjay. So it is three standard deviation away. Okay, so Radhakrishnan got around 2.89, which is almost 3. So I'm asking you how many students got above 90. That means this area I'm asking you. Okay, is it clear till now, guys? I'm asking you what is this area. Correct? Because this place is 90. This value is 90. I'm asking you how many students got above this. Okay. Now using this 3 standard deviation away, we know that this is 3 standard deviation away. 60 plus 3 into 10, you get 90. So you know that between this and you know the area of this plus this is 0.3%, right guys? Because the area inside this is, so this green area is 99.7%, right? So that means the outside red area is 0.3%. Okay, so 0.3% is the outside area, but that includes this plus this. Okay, that includes this plus this. What I am asking you is only this, not this one. I'm asking you only this. So what will this be? This will be this divided by 2 because they are equal. They are symmetrical, right? This figure is symmetrical across the average. Over the average line, this figure is symmetrical. So this means if this is x, this is also x. So I can just take 0.3 divided by 2. That means 0.15%. 0.15% of the students got above 90. So 0.15 into the total number of students will give you the answer. Yes. So 0.15 into 300, which is 15 divided by 100 into 300. So 45. No, it will be two more zeros, right? It will be two more zeros. So it is actually 0.45. So 15, it is 0.15%. So two zeros here, two zeros here, two zeros gone, 15 threes are 45 divided by 100. So the answer is 0.45 of the students got above 90. So you can say almost zero. Almost zero students got above 90. and this 0 is the score that you guys also get now. None of you gave the right answer. Okay, did you understand, guys? So how will you calculate? So using this, you can calculate what proportion of students. So whatever that number is, I asked you 90, I could have asked you any other number. Okay, I could have asked you any other number. Now let me give you another question on the same problem. Now tell me how many students got more than, let's say, 50. How many students got more than 50? So guys, please try to answer this. Now that I have shown you how it is done, please try to answer how many students got more than 50 in the exam. Okay, so use your notebook, otherwise it will go wrong. So try to draw a plot like that and then do. If you just do in your memory, you might go wrong. So use a pen and paper for that. Okay, Disha got 150. Let's see what others get. Disha, you might want to have a look again. Yeah, a little more than 150. How much is a little? You can get the exact number. Try to get the exact number, because 150 doesn't look right. 150 means 50%. Jagdish got 105. Okay. Think about the answer once. Okay. Think about the answer. How much should you get? Even if you're not able to get the exact answer, you can make a good guess by drawing the figure. So how do you make a good guess? Let me show you. So you can draw a figure like this, and you know that the average is 60. I have given you that. That marks average score is 60. So how many people got, and we know that total number of students is 300, right? I have given you that as well. So how many students got above 60? If I ask you that, what will that number be? How many students got above 60? That means this area. So how much is this area? This is 50%, right? This is 50% of the area. So that means 150 people got above 60. Okay. So that means, Jagdish, your answer of 105 is not correct. Because if 150 people got above 60, definitely more people would have got above 50. So it has to be a number greater than 150. It cannot be a number smaller than 150. Okay. Because what I am asking you is, I am asking you this area. This number is 50 and I am asking you this blue area. Okay. So it has to be greater than 150. Okay, Satisa got 165, which sounds logical. Disha got 222. So I don't know the answer. I'll have to calculate. Okay, so let's calculate. Okay, Lalitya got 252. So everybody is getting a different answer. Let's see. Let's see what is the correct answer. Okay, 210. Okay, any other new numbers? Okay, Mrityunjay also got 252. At least we have two people getting the same answer. So if I take the mode will be 252, because two people are getting 252. Okay, Suraj got 180. Okay, let's see. 200. Okay. Okay, let's see. So first we'll have to identify how many standard deviation. Okay, Devmita also got 252. So two people getting 252 and two people getting 150. Okay, let's see. Okay, so first we'll have to identify what point am I looking for. So I'm looking for all people who got more than 50. So that means I'm looking for this blue area. Okay, so I have got a range that this area must be greater than 150. The total number of students getting above 50 must be greater than 150 is what I know. Now let's calculate the exact number. So first I'll have to identify how many standard deviation away is this 50. How many standard deviation away is that number? So how do I identify that? I just do 50. So standard deviation is 10. That means if I go one standard deviation away, I will get this 50. Okay. So one standard deviation away I have to go. And what have I learned from here? Now here I have learned that if you go one standard deviation on both sides, you get 68% of the area. Okay. So that means 68% is this shaded area. What is the outside area? Outside area is 100 minus 68, right? So it is 32%. So that means this area is 32%. Okay, this area is 32%. But I don't want this area. I'm not looking for that area. Okay, what I am looking for is this area plus this area plus this area. Okay, so for that I'll have to exclude this area. So what is this area then? Now this plus this is 32%. This plus this is 32%. So how much is one of them? How much is this red area? It is 32 divided by 2. So 16%, right? So that means I have to exclude the 60% out of everything. So what remains? This green color, what is that? It is 100 minus 16, right? Which is 84. So 84% of the people got above 50. Right guys? Anybody got this number? Okay. So 84% of 300 is what should your answer be? So 2 zeros gone, 2 zeros gone. Your answer is 252. Yeah. So 252 is your answer guys. 252 people got above 50 marks out of the 300. Okay. So I guess some of you got it right. Okay, so this is how you calculate. Okay, so it can be trickier at some times, it can be very easy at some times. Okay, but all the answers you will get from here, from these three. Okay, I might have asked a even difficult question. I might have put a question like how many people or how many students got between a range. I can ask, let's say between 50 and let's say 70. How many people got between 50 and 70? Similarly, I can ask any other question related to that. Okay, not 1.5, Suraj. It is 1 into standard deviation, not 1.5. It is not 1.5. It is 1 times, 1 times, 2 times, 3 times, not 1.5. Okay. Okay, great. So this is how you do it. Okay, now, okay, I think we are already running out of time. Okay, so actually I had a few more things to discuss here. So you were able to calculate whatever question I asked, but let's say if I ask you how many people got above 65, if I ask you how many people got above 65, so do you think you will be able to answer? Okay, no Lalitya, you will not be able to answer because this information is not enough. Why it is not enough, I'll tell you. Okay, you know that the average is 60 and you know that if you go to 70 you will be able to answer because 70 is one standard deviation. Similarly, if you go to 80 you will be able to answer. If you go to 90 you will be able to answer. But if I ask you at a midpoint 65, you will not be able to answer because you only know the area within this range. not for 65. For 65 you do not know, and this graph is not linear, so you cannot extrapolate that okay, for one standard deviation it is 68%, so for 1.5 it will be 68 into 1.5. It doesn't work like that. It works like that only if it is linear. Now here it is a curve. It is a curve, so you cannot use that unitary method that it is called. Are you getting, guys, what I'm trying to say? Since it's a curve here, it's not a linear line, so you cannot use this method for all other random points. Are you guys getting? So Lalitya got it. What about the others? Yeah, exactly, Disha. It is not uniform. So this distribution is not uniform. So you cannot directly use this. That okay, for one it is 68, so for two it will be double of that. No, it doesn't work like that. It is non-uniform. It is following sharply as a curve. So for that you will have to use the software. You cannot use that. So for that we will go to R and we will run some functions there. Okay, so we will see that tomorrow. We are already out of time. But if I ask you these numbers, which are whole numbers in terms of standard deviation, so one standard deviation or two standard deviation or three standard deviation, then you can directly calculate because you know these terms. But you cannot memorize this for everything, right? You cannot memorize for 1.2, 1.3, 1.5 sigma how much area you will cover. You cannot memorize for everything, but these three we commonly memorize. But others we don't memorize. We take help of software to calculate the others. So that's what we will do tomorrow. Okay, so today let us stop. We are already out of time, so we will stop it here. So we will do a revision now of all the statistics that we covered. So guys, was it clear whatever we covered? I know we covered something which you wouldn't have seen so far in your career. Maybe some of it was high school mathematics, but you might have forgotten, and some of it was quite complex, I would say. Okay, so let's do a revision, and if you have any doubts you can ask during the revision. Okay, so let me save this. And I'll open up a new sheet. Okay. Yeah guys, so first let us review the stats part, and then we will quickly review the R part also. First of all, any doubts before we start the revision? Any doubts so far? Whatever was covered today, do you have any doubts? Anybody? Guys, don't feel shy. If you have doubts, you can ask me. Or if you feel shy, you can ask me as a private message. You can just message me and ask, okay? Keep your doubts to yourself. Okay. So let us start the revision. So first we'll cover the stats part. So we saw a few distributions today. The first distribution that we saw today was, okay, so a bit confused about how to apply the formula x plus sd. Okay, so yeah, I will cover that. Okay, so I'll cover that during revision. Okay, so what did we see today? We saw what is uniform distribution. We saw what is uniform distribution. So uniform distribution is when it stays uniform. When the histogram stays uniform, it doesn't fall. It doesn't rise or it doesn't fall. That's when we call it a uniform distribution. Okay. So the frequency remains the same basically. It does not vary. Okay. Whatever it is. So here it is 5. So what will be the equation here? The equation of the histogram will be, or the curve here will be, y is equal to 5. Y is equal to 5 is the equation of this curve. Okay, so that is a uniform distribution. Similarly, we saw triangular distribution. What is a triangular distribution? A triangular distribution is where you have a minimum and you have a maximum, and you don't know what else, where it, how it varies, you do not know. You just know that you have a minimum and you have a maximum. So it is very similar to a triangular distribution. Now it might be any kind of a triangle. It might be this, it might be this, it might be this. It can be any kind of a triangle, but it will never be less than this, it will never be more than this. That's what you know. This is a triangular distribution. There is some equation for this graph also, which I don't remember. Okay, it is a function of the minimum value and the maximum value. Okay, so that's about triangular distribution. The next one that we saw was a normal distribution, the most important one. Normal distribution. Later in our course we will also see something called Poisson's distribution. Okay, we will see something called Poisson's distribution later in the course, but the most important is normal distribution. So normal distribution looks like a bell curve, and the equation of this curve is a function of the average value, which is here in the middle, and the standard deviation. It is a function of the average and the standard deviation. Okay, the equation of the normal distribution. Now if we have to now through statistics we can find a few parameters. So let's discuss those. So it tells us, statistics tells us that now this figure is symmetrical. Okay, it has 50% area below the average, it has 50% area above the average. Okay, now what statistics tells us, it tells us that if you go one standard deviation on both sides of the average, okay, I'm going both sides plus minus, it tells me that you get 68% of the area. That means if this is one standard deviation, this area is 68%. Okay, similarly if you go two standard deviation away, so this is x bar, two standard deviation away, you get around 95.5% area. Okay, this is two standard deviation away, this is one standard deviation away. Similarly if you go three standard deviation away, you get almost everything. If you go three standard deviation away. Okay, so you get almost everything. Only a very small portion is left. Okay, only a very small portion is left. So this is what the normal distribution tells you. So you can utilize this information to compute the examples which we discussed. Okay, so first task is you have to do is you will draw the histogram. And you will mark the average which I have given you, which the question has given you. Okay, now once you have the average, you'll have to see what is the question asking. So let's say the question is asking you beyond certain point. Now if that certain point is some whole number of standard deviation, either 1, 2 or 3, let's say this is 80. So 80 means it is two standard deviation away, right? Because 60 plus minus, what will you add here so that you get 80? You will add 20, right? And 20 is how many standard deviation? It is two standard deviation, 2 times the standard deviation, because standard deviation is 10. So that means if you go 2 standard deviations on the higher side, you get this point. So that means you will have to calculate this area. The question is asking for this area. Now you know that this area is 95.5%. Okay, if this area is 95.5%, that means the remaining area is 4.5%. This red area is 4.5%. But I am not asking you both the red areas. I am asking you only on one side. So that means 4.5 divided by 2. So 4.5 divided by 2. Okay, so that is how you will calculate what proportion of this area is above or below a certain range or a certain value. Okay, that is how you decide. Okay, so watch this video once again, maybe later tonight or tomorrow morning. Watch it again or watch it multiple times if you want to understand. I'm sure you would have understood already, but if you watch it 2-3 times, it will become even clearer. And in this coming week's assignment, I will give you a few problems on this. Okay, I'll give you a few problems on this which you can solve. That will make it clearer. So this is what we discussed on the statistics part today. Okay, guys, clear, everyone? Okay, and on the R part, I think we have already done a review, right? So what commands did we see on the R part? We saw how do we create a list. So we use the list function, and then we give as inputs two vectors. Any vector, any name. If you want, we can give a name, or if you don't want to give a name, you directly give vectors. You can directly give vectors also without giving a name. So let's say 1, 2, 3 and AB. You can give directly. So we can access individual vectors of a list by using double square brackets and the index. Okay, so double square brackets index will give you one vector, and if you have to access individual element from within a vector, you can use a single square bracket. So this is a list. Okay, next we saw what is a data frame. Data frame, very similar to a list. It is a combination of vectors where all vectors must be of same length. Okay, all must be of the same length, otherwise you will get an error while creating data frame. Okay, then we saw how do we access, so how do we create a data frame? We just use data.frame function, data.frame, and you write the vectors that you want. Okay, so this might be vector 1, this might be vector 2, vector 3, and so on. Then we saw how do we access individual columns from a data frame. We write data frame dollar the column name. Okay, whatever column name you have, or you can also use data frame. You can use normal matrix like indexing also. So let's say you want the second column, then you can write 2 here, or let's say you want second and fifth column, so you can write 2 and 5 here, just like you would do in matrix. In matrix also you would do the exact same thing. So this means that you want all the rows and second and fifth column. Okay, then we saw what is Rbind. Rbind is used to place one vector over the other, one data frame over the other. So row wise merging, that is why Rbind, R for row. Similarly, Cbind we saw, where you just have to bring one column and attach it adjacent to another data frame. Okay, C for column. So this is an existing data frame. You just bring another data frame and put it besides it. So here both has to be a data frame. Okay, similarly here also both has to be a data frame. You cannot place a vector here besides it. It has to be a data frame only. So even if you want to put one column, you can just convert it first to a vector and then bring it besides it. Okay, and by the way guys, if you have to create a new column in a data frame, so the moment you write data frame dollar, you get some options, right? The existing options you get. So that way you can access individual columns. But let's say you have to create a new column, so that you can do dollar, you write a new name. You write a new name which does not exist and give some values. That way you can create a new column also. Okay, it's very easy. So if I have to show you here, so df is my data frame. If I have to create a new column, I can write data frame dollar, let's say temperature, the average temperature in that country. I have 3 countries, so I'll have to give 3 temperatures. Okay, so let's say for India it is around 35 degrees Celsius. For USA it's pretty cold, so 20. China it's let's say 24. So this way I can create a new column in my data frame. So now my data frame will have an additional column called temperature. Okay, just give a new name, it will create that new name, but make sure you give the same number of elements as the other vectors in the data frame has. Okay, if I gave just 2 here, it would not work. It will throw error. See, I'm giving only 2. It gave me error. Replacement has 2 rows, data has 3. So that way it doesn't work. Okay guys. So this is the Rbind and the Cbind function. The last thing that we saw was how do we apply some filter on a data frame. So we saw that whatever condition we want to use, we can apply on the rows here. We write the condition here. Here we give the columns that we want. So you can write data frame, and you can write whichever column you want to apply that condition. So data frame $column is greater than equal to, let's say, 2, and you can write column number 1 and 5. This will give you both column 1 and 5 as the output. Okay, only for those rows where this condition is true. Or you can make it one dimensional at the beginning itself. You can write the column name so that it becomes one dimensional at the beginning. Then you don't have to use the comma. You can directly use the condition. Okay, so is that clear, guys? Today's class, how was it, guys? So was I going at the correct speed, or was I going too fast, too slow? Any feedbacks? So feel free to give feedback, okay, guys? If I'm going too slow, you tell me that you can speed up a little. Or if I'm going too fast, if you're not able to follow, please tell me that I'm going too fast so that I reduce my speed. Okay? Okay. And I hope you guys are understanding everything, okay? If you don't understand, please tell me. I'll be more than happy to revisit the concepts again. But please make sure you understand everything, okay? Data science is difficult, guys, so the basics has to be put correctly. So make sure you are understanding everything. Because at later point of time, it will be very difficult to come back to these basics and revise again. Of course we will do, but it will become very difficult. So make sure you are understanding everything correctly. But please work hard as well, okay? Don't just rely on attending the classes. Just attending the classes will not be enough. For now it might be enough because we have just started with the course, but at later point of time you will realize that you will have to do a lot of self study also, because the things taught in class will be pretty new to you. So only if you revise them again it will become clear in your mind. Otherwise you will forget again. Okay.